Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today we are diving into a subject that feels straight out of science fiction, but it's very real, and its potential impact on defense and energy is massive. We are talking about neutrinos, tiny, elusive particles that pass through everything, including you and me, by the trillions every second. For decades, they were mostly a mystery to physicists. But now, they're at the heart of a technological revolution that could reshape the way militaries think about power, security, and even warfare. Let's start with what makes neutrinos so fascinating. They're near-mass, have no electric charge, and can travel through miles of solid matter without leaving a trace. That's part of why they're so hard to detect, but also why they hold incredible promise. Recent breakthroughs have shown that neutrinos do, in fact, have mass, and that opens the door to using them not just for science, but for real-world applications. One of the biggest: energy. Picture a power source that runs 24/7, isn't affected by weather, and doesn't rely on sunlight or wind. That's the vision behind voltaics energy harvesting from neutrinos. Researchers are exploring special nanomaterials like graphene to absorb the kinetic energy of neutrinos and convert it into electricity. It's still early days, but if scalable, this could revolutionize decentralized energy. Imagine powering military outposts in remote areas without ever needing fuel resupply. China is taking this seriously. They've built a massive underground facility called the Jiangmen Underground Neutrino Observatory. It's designed to study neutrino behavior, but beyond that, it's laying the groundwork for applications in energy, nuclear monitoring, and national defense. Over 600 scientists from 17 countries are involved, which tells you how significant the research is. Now, let's shift to something even more dramatic: neutrinos as a tool for nuclear security. Since they're produced during nuclear fission, they can serve as an invisible fingerprint. That means they could be used to detect hidden nuclear weapons, submarines, or reactors without the need for physical proximity. You can't jam them, you can't block them, and they can even travel through Earth, making neutrino-based surveillance a potential game-changer for monitoring global nuclear activity. There's also a wild idea that's being explored: using focused neutrino beams to actually disable nuclear weapons. In theory, these beams could disrupt the chain reaction inside a warhead, making it impossible to detonate. It's still very theoretical. Engineering a neutrino beam strong enough would require infrastructure bigger than any particle accelerator we've ever built, but it shows just how seriously researchers are thinking about neutrinos as more than just passive observers. On the communication front, neutrinos could solve some of the military's toughest problems. Think about submarines. They can't communicate underwater without surfacing or using relay buoys, both risky. Neutrino-based communication would allow them to stay completely submerged and still transmit messages securely. No interception, no detection. Just quiet, secure, global communication through solid rock or water. The same applies to battlefield intelligence. Neutrino sensors could detect hidden bunkers, underground missile silos, or secret nuclear facilities. You wouldn't need to fly drones overhead or send in ground forces, you could literally see through the Earth. Even space-based neutrino detectors are being discussed, giving rise to the idea of persistent, non-intrusive global surveillance. Of course, there are massive technical hurdles. Neutrinos are incredibly hard to detect. The observatories we use today are enormous, like Ice Cube in Antarctica, which covers a cubic kilometer of ice. Shrinking that kind of detection down to fit inside a satellite, submarine, or soldier's backpack is still a long way off. We also don't yet have the energy infrastructure to build high-powered neutrino beams. To do what scientists dream of, disable warheads remotely or power entire cities, you'd need accelerators that are hundreds of kilometers wide and consume gigawatts of power. But even if we can't get there now, research is pushing in that direction. Artificial intelligence, nanotechnology, and quantum computing are expected to play a key role in this evolution, making it possible to sift through faint neutrino signals, miniaturize detectors, and build smarter, more adaptive systems. Some of these could be operational within the next couple of decades. In short, we are looking at the dawn of a new frontier where these ghost particles could shape the future of global security. From powering the battlefield with invisible energy to rendering nuclear threats detectable or even neutralized, neutrinos might just become the most strategic particle in modern defense. And while much of this is still theoretical, the foundations are already being laid. As the technology matures, neutrinos could shift from being the stuff of physics textbooks to being the invisible force behind 21st century military strategy.